Hey, I'm Itay, and this is Lab 10 laser diodes and light emitting diodes, LEDs and LDs.
Hi, I'm Dror Sapir. In this lab, in part 1, we looked at the physical and power characteristics of laser diodes and LEDs in a few different ways, and then in part B, we looked at the beam divergence and the radiance characteristics of LEDs and laser diodes, and in part C, we looked at the spectral characteristics of LEDs and laser diodes.
We changed the angle, we got different powers on our detector, and this is the data that we got on the computer.
Okay, so we have the peak-to-peak voltage values, and our angles are going from -90 to 90. These are the values that we got, and they gave us a nice smooth graph, just like we expected. Now we rotated the laser so it's horizontally aligned, and we're going to repeat the same procedures as we had when it was vertical. This is our data. When the laser diode was vertically aligned, we went in increments mostly of 2 degrees. And we got this very sharp curve because it takes a very small vertical area. And right here, when it's aligned horizontally, we had to use about the same increments, but we had it went over a much larger space. Ruler here on top of the LED, and we're getting a reference. And Itay measured the distance between 2 notches of 1 millimeter.
And we measured the length of and the width of that.
Okay, so now we're at 1.62 volts, and we're saturated at about 2 volts. We can see that the laser cavity is very much smaller than in the LEDs, and it's when we turn it up, it's putting out much more light from a much smaller source. So now we have the red LED facing the integrating sphere, and we're going to cover it up, and we're going to check the input voltage versus the output in microwatts. The length and width of all of the LEDs, and we got the length of the laser cavity, and we converted them to millimeters right here. Laser diode, this is the input current to output power in microwatts, and this is for the red LED. And as we can see, the graphs are a little bit different. The laser diode jumps up at about 20 milliamps, and the red LED is more steady. They can make white or they can be turned on separately, and we're going to find, for each of the LEDs, we're going to find the peak wavelength, and we're going to find the bandwidth, which is right here. These are the bandwidths and peak wavelengths that we got. Diode is going through apertures, hitting mirrors, and again hitting the mirror, going through this aperture, and then getting coupled into this fiber. So changing the reference level gives us the preferred mode. So as the current goes up, the peak shifts to the right.